Okay, welcome back, and now we're going to do a plumbing example, and there are lots of situations where we have to find that we have to determine whether or we have to determine what size circle would have the same area as some a bunch of smaller circles. Okay, so let's read this example and then we'll jump in. It says, suppose we must determine the diameter of a water main with the same total area as two mains with diameters of 3 inches and 4 inches. Okay, so let's read this again. Suppose we must determine the diameter of a water main with the same area. Okay, so let's draw pictures, right? So let's draw pictures. So here's one main, right? And here's another main. And here's another main, right? And so we need to determine the diameter of this one, right? So let's call this D. And we've got the diameter of this one, and we know the diameter of this one. So what are the diameters of the smaller mains? 3 and 4 inches. So let's say this is 4 inches, and this one's 3 inches. Now what we do know is that this has the same area, this circle has the same cross-sectional area as these two added together. So let's say A, so the area of this main is equal to the area of this main plus the area of this main. Okay, that's what they're saying, right? All right. Now, let's see if we can figure out the diameter. How are we going to do this? Well, since we're dealing with areas of circles, right? We know that the area of a circle is pi r squared, right? So let's go over here. So area equals pi r squared, right? But since we're dealing with diameter, we can still find the diameter and just deal with radius. If we find the radius, then we just double the radius for the diameter. So let's do that. So again, so this is going to be pi r squared is equal to pi, and let's call this r1 squared plus pi times r2 squared. Well, if this is d1 is equal to 4 inches and d2 is equal to 3 inches, well that means that r1 is equal to 2 inches and r2 is equal to 1.5 inches. Okay? That should make sense, right? So now all we have to do is plug in here. Well, let's simplify this a little bit. This is going to be pi times r1 squared plus r2 squared, right? And in fact, this is going to be equal to pi r squared, right? Well, guess what? The pi's are going to cancel out. So look at that. So the radius squared of the first circle, the one main, the larger main, is equal to the sum of the squared radii, the sum of the squared radii of the smaller mains. So we end up with this equation. And by the way, what do? Well, we get r squared equals what? r1 is 2, so we get 2 squared plus 1.5 squared. Well, this is just going to equal 4 plus 2.25. Okay? And then this is just obviously going to equal 6.25. Oh, this is a good one. So if I take the square root of both sides, I get r equals plus or minus the square root of 6.25, and I know this one. So this is going to be plus or minus 2.5. Okay? Okay, and so now so that means R is equal to plus or minus 2.5 inches, which means the diameter is going to equal plus or minus 5 inches. And so now, again, for an application problem, we ask ourselves, does the answer make sense? This is saying that the diameter, right, that the diameter of the main here is either equal to 5 inches or negative 5 inches. Can they both be right? And in this case, the answer is no. The negative diameter makes no sense, right? You can't have a negative distance when you're measuring diameter of a pipe. So this is wrong. So the answer is just 5 inches. And we're done. Have a great day.